write each expression as a single trig ratio. Evaluate where possible. I actually think that they didn't do the greatest job here in example A. Okay? Do you know that cos of pi over 4 is root 2 over 2? And you know that sine of pi over 4 is also root 2 over 2. If I got question A, I would definitely do it like this. Well, maybe if my pen was working. There we go. Well, if cos of pi over 4 is root 2 over 2, does it make sense that cos squared of pi over 4 would be root 2 over 2 squared? Minus, well, sine of pi over 4 is also root 2 over 2, and if that got squared, this is obviously 0. That's easy mental math. I don't think I would recommend using an identity for this one at all because this is too easy to do directly. What did they want us to do in A? They wanted us to recognize this formula. You have a cos squared theta plus sine squared theta is 1. Now you have a cos squared theta minus sine squared theta is cos 2 theta. So what they wanted you to do is say, hey, this is the right side of this formula. But instead of theta, I have pi over 4. So I could rewrite it as cos of 2 times pi over 4. Can I simplify that? Well, that's 2 over 1. How do I multiply fractions? Multiply the tops, multiply the bottoms. That's going to be cos of pi over 2. Is that on your pi plate? Absolutely. What's cos of pi over 2? X coordinate? It's 0. Same answer as we had before. Question?
Why is your X not a liar there?
In which place? The 2?
The 2, yeah.
Well, it's just math here in the brackets. X's are liars when we want to go about graphing it from our original graph, but we're not graphing right now.
Okay.
It is a liar in the sense that what normally value you got from pi over 4 now is at pi over 2 doubled, right? And so you'd have to cut that in half to get the regular pi over 4, and that would be the liar part, but we're not graphing, so I wouldn't worry about that. Okay. So definitely in that first one, I don't think it's a good question because they used a value that you could plug in. Same thing happens in the second one. Do you know tan of pi over 6? Yes, root 3 over 3. If you were asked to evaluate this, you definitely could do that directly. They want you to write it as a single trig ratio. That's where they're saying use your formulas. So what we're going to do for part B is we're going to write out our formula for tan 2 theta, which is 2 tan theta over 1 minus tan squared theta. And we're going to look at what we have and say, does it match up? Do you see that it's close, but not exactly? The formula says you need a 2 tan theta on top. Do we have a 2 tan something on top? Yes. And the bottom says you need a 1 minus tan squared. Do we have a 1 minus tan squared something on the bottom? No, we have a tan squared something minus 1. So you would have to do some algebraic manipulations to make it match up. And the algebraic manipulations are going to look like this. So I have 2 tan pi over 6 on the top, and I am going to take out a negative 1 on the bottom. Can you see that taking out a negative 1 would make the previous negative 1 positive? So I'm going to write that first because it's written first there. It's going to make the tan squared thing negative. And mathematics and fractions and negatives. Okay, just off to the side here. Would you agree that if you had a fraction with a negative on the bottom, that means exactly the same as that same fraction with a negative on the top? which means exactly the same as that same fraction with the negative out front. All of those things in mathematics are the same thing. If you have a negative in a fraction, you can choose to have it on the bottom, on the top, or in front. In this situation, I'm going to put that negative out in front. Then what's left would be just this part. And this part matches up perfectly with the formula. So you're allowed to use your identities when they match up perfectly. If they don't match up perfectly and you try to say, oh, I'm going to make something up, that's bad. It's not going to end well. So now that green box, I can replace that with tan of 2, and my theta was pi over 6, which ends up being negative tan, multiply this out, pi over 3. Is pi over 3 on your pie plate? Yes, it is. Tan of pi over 3 is root 3, so I'd have negative tan of pi over 3 would be negative root 3. Now these questions, I would say, are not the greatest because they use things that were already on your pie plate, so you could have skipped the identity. But you will get some questions where these are really important, and I'll show you a couple of those. Yes?
If you write it with like the tan, tan squared pi over 6 without the brackets around pi over 6, is that an error?
No,
Or is that like fine?
that's fine.
Okay, I just
But
want
you
to.
can put that in brackets as well if you'd like. Yes. So I'm going to add a C to this question. For C, I am going to write evaluate without a calculator 1 minus 2 sine squared of pi over 8. Specifically chose pi over 8 because that is not on your pie plate. Definitely not on our pie plate. And this is non-calculator. So unlike A and B in the textbook where you could do it without doing any formulas, you have to use a formula here. Does this match up with any of our formulas on there? Yes, it's one of the cos. It's one of the cos ones, so you could say I could rewrite this as cos of 2 times pi over 8. Why is that helpful? Well, if I simplify that, it becomes root 2 over 2. I'm going to give you one more example. Do you want it crazy hard or just okay? What do you feel? You want the crazy hard version or the okay? They're very similar, but I can just do one little thing to make it crazy hard. I'll give you okay. People wanted the crazy hard one. You guys are crazy. Okay? I want you to evaluate sine of pi over 12. Remember pi over 12 from yesterday? Times cos of pi over 12. By the way, yesterday, pi over 12 questions when they're on tests or on the exam are usually out of 4 marks. Sometimes they put them out of 3. Usually out of 4. That's one of them. So if I just give you sine of pi over 12, it's a 4-mark question. If I give you cos of pi over 12, it'd be another 4-mark question. If I put both of them in the same one, you kind of feel like it should be an 8-mark question. Yet on the exam, this is probably 2 marks, maybe 3 marks. Because it's crazy hard, it's 3 marks. When you see this question, what makes this crazy hard is you're probably tempted to do pi over 12 questions. Does it make sense when you see pi over 12 that you might think that this is a pi over 12 question? Kind of make your brain sort of trains you that way. But this can be done much easier and much shorter with one of our formulas. Can you see which formula it kind of matches up with? How does it almost match up with this formula? You see, you sort of have an alpha here and alpha here. What's the problem we're missing? We're missing,
Two.
well, we're missing a 2 out in front, right? If it would match, like, if I just gave you the difficult one, I would have put the 2 out in front right away, and it would have matched up perfectly. In mathematics, you can be creative. If something's missing, oh, I'm missing a 2. Well, if it's missing a 2, put it there. Is that allowed? No. But it's allowed if I also put times by a half. Because what's 1/2 times 2? 1. And now, if I break it up there, that now matches my formula perfectly, and I just have this extra half out in front, but the rest of that is going to be sine, there we go, of 2 times pi over 12. Oh my goodness. That's sine of pi over 6, which is a half and a half times a half. This is 1/4, which is a lot quicker than having done the pi over 12 questions twice and multiplying both those root 2 plus root 6 over 4s times each other. Okay. Circle questions 4, 5, and 6.